Hi, I'm John Accardo, Senior Applications Engineer for Siemens Clamp-On Ultrasonic Flow Meter products. And this is the SITRANS FUH1010 Hydrocarbon Liquid Flow Meter. The FUH1010 has the unique ability to measure multi-product pipelines, simultaneously indicating flow rate, identification of the flowing product, dynamic density and viscosity measurement, plus liquid interface and pig recognition, all from outside the pipe. The FUH1010 can be customized to your specific range of products through the simple process of optimization of its integral liquid table. In this presentation, I'm going to introduce you to the liquid table and the optimization process. You will learn how the FUH1010 identifies a liquid, what the liquident parameter is, how to read fluid gravity data, how to verify liquid data accuracy, how the liquid table is constructed, and how to optimize the liquid table. How does the FUH1010 identify liquid? After all, hydrocarbon pipelines are dynamic environments with highly changeable conditions. Liquid temperature and viscosity are variable. Line pressure may vary. Multiple products may be transported through one pipe. How can the FUH1010 maintain its accuracy under these conditions? The SITRANS FUH1010 meter utilizes a built-in liquid table to identify the liquid in the pipeline and its characteristic density and viscosity. This table is the foundation of system performance. The key to this ability is the parameter liquident. What is liquident? The speed of sound, also known as the sonic velocity of a hydrocarbon liquid, is used as an identifier. But sonic velocity alone cannot identify a liquid because sonic velocity changes with temperature. Therefore, an individual value could correspond to multiple liquids. By correcting the actual sonic velocity to a reference temperature, for example 60 degrees Fahrenheit, the meter can positively identify the liquid. This is possible because sonic velocity changes linearly with temperature. This normalized sonic velocity value is called liquident. Let's have a look at the liquid table parameters, which can be found in the Application Data section of the menu. The liquident slope indicates the rate of change of sonic velocity versus temperature and is preset for hydrocarbon liquids. There is also a pressure slope correction if pressure data is input to the FUH1010 meter. The base temperature is preset to 60 degrees Fahrenheit, but can be programmed to another value if needed. The liquident index parameter expands to illustrate all liquids programmed into the liquid table. As delivered, it is preloaded with a generic range of light hydrocarbons to heavy fuel oils, the details of which are covered next. Selecting the liquident index parameter will give you access to all liquids currently programmed into the meter. Each liquid is represented by a liquident value, which is its sonic velocity at base temperature. Each liquid's individual parameters are editable, and additional liquids can be added. Each entry identifies the liquid by name and contains its density and viscosity at base temperature, along with its thermal expansion coefficients. How does the FUH1010 compute liquident and apply liquid table data? The FUH1010 measures actual liquid sonic velocity and liquid temperature. Liquident is calculated using the liquident slope factor. The liquident value identifies the measured liquid in the liquid table, along with its base density and its viscosity. The FUH1010 then computes density and viscosity for the actual liquid temperature. Actual density and viscosity data enables dynamic Reynolds number compensation, standard volume correction, or mass flow measurement. When you receive your FUH1010, its liquid table is in generic form. This simply means that its indication of liquid density or API gravity and viscosity may not precisely match your specific liquids. This is why optimization of the liquid table is necessary. Optimization is a one-time, relatively easy adjustment of your liquid table to align it with your specific products. How is the liquid table optimized? Optimization is an exercise of collecting density and viscosity data for your actual liquids and matching them to the liquid table. When the values do not agree, an adjustment to the liquid table is made, which can be thought of as an in situ calibration. Reference data can be acquired from your own lab or from field samples. The values should be for your liquid at base temperature. This data is then compared to the indicated values displayed in the FUH1010 diagnostic menu. This can be done in real time by comparing your data to meter diagnostic values. Timestamp samples can also be collected for a longer time frame, for example 1 week, and compared to data collected from the FUH1010 data logger. The procedure is the same either way. If a liquid sample is taken, density and viscosity must be determined with the use of laboratory equipment. The values must be for your liquid at base temperature. Then compare these reference values to the values indicated by the FUH1010, which can be found in the liquid data section of the diagnostic menu. If there is a difference between the values, note the indicated liquidant value. Access the liquid table in the application data menu. Choose the existing liquidant index closest to that noted in diagnostics. Then modify it to the liquidant value noted. Alternatively, choose Add Index to input a new liquidant value. Now enter the reference density and viscosity data for base conditions. You can also rename the liquid to match your product. Thermal expansion coefficients K0 and K1 are based on product family and can be found in the FUH1010 installation manual. With all data entered, press the left arrow to exit. Repeat these steps for each liquid sampled. Once you have observed each of your liquids and optimized the liquid table values for them, the liquid table is now complete and optimized for your product range. It should not need further adjustment unless a new product is introduced to the application. If you have questions about what you have just viewed or need assistance while programming your meter, you can always speak directly with a qualified field engineer by calling one of the Siemens regional support hotlines.